dirt bike ready for him to drive, like a nice size hole for him to ride a dirt bike. Like,
see, when I first heard it,
and then
I thought it was like jail, and then I realized it was like maximum security prison. I was like, fuck.
Alright, cool. So we're gonna break out of prison. The idea is, for those of you who had me for 1C, some of you guys didn't. Okay, that's cool. But the idea is that some of you guys never had Algebra 1C or learned this at all. So I had to kind of take a mo, and we're going to stop and we're going to remind or remember how to simplify radicals, how to multiply radicals, because that's going to help us when we get into special right triangles. Rationalizing denominators, because again, that's going to help us with special right triangles. And then last but not least, we're going to actually talk about what the hell we need to talk about, which is the geometric mean. The geometric mean is ultimately coming from a relationship inside of triangles, but when I taught it the first time, it went over everyone's head. So we're not doing it. I'm making it nice, simple, and to the point.
You're not gonna teach it?
Well, no, I am.
Oh.
Alright, so, breaking out of prison. This is how we simplify radicals. We have 3 steps. Step number 1. There you go, Nessa. You need what?
I need a partner.
You need an escape partner.
I'm gonna ask Cassie. N-E-R.
Okay, just didn't look right. Okay, perfect. Not that I don't know how to spell or anything. Which ultimately means the same number twice. That's your escape partner. You need to have the same number twice. 2 2s, 2 3s, 2 5s, 2 7s. You need to have the same number twice. What's step number 2?
One of them dies. Cassie's gonna die.
Okay.
I decided.
One of your partner dies
The other escapes.
while the other escapes. That's funny. It's spelled just like the word escape.
I guess they played a lot of rock, paper, scissors.
We have to figure out which one of you guys are
No,
doing.
I'm just.
Because if you think back in the movie, they all went out in 2s. They always had their partner that they were going out with. It was like they worked together. I don't know. Well, and I did tell you that Hitler did sentence 50 out of the only 3 were saved. 50 of them were shot. They were caught. They were then caught after they left. So it really defeated the purpose.
Yeah, for
The
real.
movie yesterday, the story, the actual Great Escape, 50 of them, technically 53 of them escaped. End all be all. 50 of them were recaptured, so 3 technically escaped. And then Hitler sentenced the other 50 to be shot and killed.
That's what movie you were watching
The
yesterday.
Great
The Great
Escape. Maybe
Escape.
if you didn't sleep, you wouldn't know.
No.
Sure.
The last thing. Problems
Inside and outside
inside and outside
of prison multiply that has never been more true.
prison multiply. When I say multiply, I mean we are going to times. We're going to multiply. There's going to be multiplication involved. So in problems inside and outside of prison, multiply. So
You just get off the plane, of course, it's gonna be a lot of
yeah. You're just trying to escape it.
I did escape. Cassie did.
You tell her that.
I will tell her that. No problem.
Okay. Let's do 2 examples, and then Nessa will do 2 examples because she really wants to teach it. Okay. So problem 1. Let's do the first guy. Let's talk about it. Let's do it. Let's have fun. So when they are inside of a radical, the radical is supposed to act as the prison. So they're stuck inside this jail cell. So we have 20. You want to break down 20 into 2 numbers. What 2 numbers can I multiply to make 20? We can do 10 and 2, 5 and 4. I heard 5 and 4 first. I'm going to go with 5 and 4. Like I said in the warm-up, it doesn't matter where you start. You're going to break it down to its prime factors and they're all going to be the same. Can I break down 5 much more than 5?
No.
Underline it, please. So when you get to a prime number, I want you to underline it. What did you do, Andrew? That's fine. I'll show you why you don't want to necessarily circle. The reason you at least want to underline it is because I don't know how many times I teach this. It always happens that we forget one of the guys. We're like, I have no number. And I'm like, you have a 5 right there. And you're like, oh yeah. So if you underline it, it's like, hey, it's like a pointer to say, hey, this number means something. Where does it got to go? How can I break down 4? and 2. Anytime you break down a number, cross it out so then you don't think it's one of your possibilities. Okay? So we have 5, we have 2, we have 2. Problem 1 is, gotta have a breakout partner. Do we have any of the same number twice? 2. Circle your partners. That's why I don't want to circle. Okay? So, we have a partner. We have 2 2s. What happens to one of my partners? What does step number 2 say?
One of them dies.
One of them dies. I am very vicious in the beginning, and then I get tired of viciousness. I killed it. You see why it's red? It's blood. I killed it. The other one escapes. So that 2 gets out of prison. That only happens if you have more than one thing. Who's still stuck inside prison? Who never had an escape partner? 5. So step number 3 will come at, we'll get it there. Step number 3 is going to come in the end. So our simplified radical, the square root of 20, is equal to 2 radical 5. They'll give you the same decimal. So if I put in the calculator, square root of 20, I'll do it right now. The square root of 20, the decimal, I'll give you the rounded because it won't stop. It's never ending. The square root of 20 is 4.47. 2 radical 5, oh, let me guess, 4.47. They're the same. It's a simplified radical form. When I ask you that I don't want decimals, I want you to do this. You're going to be simplifying. Okay? Let's do the next example. Square root of 32. Perfect. So you break down 32 into 8 and 4. How can I break down 8? 4 and 2, 2 and 4, doesn't matter. How can I break down 4? 2 and 2. So 2, 2, and 2. I have some prime factors. I'm going to underline those suckers. Yep, don't forget about your other 4. How can I break him down? 2 and 2. Do I have any partners?
You have a lot of partners.
I have a lot of partners. 2 and 2? 2 and 2. Yeah. What happens to one of your partners?
Kill him.
Not all of them. One of them. So one partner from each dies. Don't kill both of them in one circle. One partner from each dies. Now, whoa, go ahead.
Why did you circle the 2 center tiers? Not 2 primes.
Doesn't matter. You can
Doesn't
circle.
matter.
Nope, it doesn't matter.
Okay.
Okay, this is where step number 3 comes about. Step number 3 says problems inside and outside of prison multiply. Well, these are my escapers. I have 2 partners. So, problems inside and outside of prison multiply. So what's 2 times 2? 4. So 4 gets out of prison.
4 radical 2.
And 2 never had a partner to escape. So 2 is stuck. So the simplified radical form is 4 radical 2. Mind you, that if you have the square root of a perfect square, you should know that. Don't break it. Okay, so if I gave you the square root of 36, don't forget that you know the knowledge. You should know what the square root of 36 is. 6. Okay. I'm going to fix it as you do these. Okay, Ness is going to do number 3 and 4. Sure, you can do any color. In 5 minutes.
It's like 10.
10 or 9.
Give me 2 numbers, guys.
9
You guys aren't just talking.
2. 9.
Okay. How do you break down 9?
3
Whoever's talking, I'm gonna give you a candy because you're the only one participating.
Alright, you go now.
Okay, now what do you do?
Underline it.
I'm violent. I don't like him. Okay.
Cross out 9.
Yes, go cross out your 18 and your 9, Nessa. Okay.
Okay. What goes in the radical?
2.
Very much. Circle your answer.
Hold on.
Wait, did you
Pause.
multiply those 2?
Oh.
And the
Okay, hold on.
Say, what's that 2 in front of that
You're
8?
supposed to leave it and then multiply at the end.
What are you doing?
You're welcome.
Are you pushing your
And you
apple?
wanna keep
Hey,
lesser.
let me.
You know how many
she's
times
starting.
I've done this? I've
Okay.
done this like 10 times.
Don't forget about the 2 out in front. 2's coming to pick up your guy. Here I am. I'm a 2. I'm coming to pick him up. So 2.
See your escape route?
Yes, exactly. He's coming to get him out. So 2 gets multiplied to 3 radical 2. We segregate. We only multiply like terms. 2 and 3 are the only like guys. Radical 2 ain't a friend. So what's 2 times 3? 6 radical 2. Okay. Go ahead and try number 4 correctly next time.
I know how to do it correctly.
Don't forget the 9 out in
It
front.
just seemed like you were
She's just setting up a lesson.
No, come right here.
Just setting up.
What'd you say?
I was
What'd you
testing
say?
you guys. I like looked at it right as I circled it, and I was like, oh shit. I forgot to do this.
Hey, we have a video, yeah. Okay. Go ahead and do example 4.
No, I don't want blue. I'm being picky. Give me 2 numbers.
96.
Oh wait, no.
9 and 6 don't work.
8 and 7.
8 and 7.
I was about to say.
9 and 6 is 54.
I was like, no, 8 and 7 work?
8 and 7.
Yeah, sorry. I'm
Cross out 56.
saying. Okay. Can you
Underline
simplify?
7.
Can you simplify any of these numbers, please?
Break down your 8.
Five,
Cross
five.
them out.
So went to
She's very vicious, even with the red.
Okay. One of your partners made it out, so I'm gonna put him right here for right now. Port 2 and Port 7 never had a partner to escape, so I'm gonna put them in there. And they can talk about how they wish they were out of jail.
It's not 2 point. Make a bigger dot right there. Thank you.
This lovely 9 is coming to save his butt so the guards don't shoot him. And so now what do we do?
18.
Perfect. So that number on the outside comes to pick them up. Remember. You multiply. So 9 gets multiplied to our 2 that escapes. And our problem 3, or step 3 I should say, says problems inside and outside of prison multiply. Both 2 and 7 are stuck in prison, so that's why we had them multiply. What? 7 minute. I don't know where my notes are.
Oh,
Oh, I'm like, I don't know where they went. Alright, next guy. Multiplying radicals. So this is where I say we segregate. We only multiply like terms. So if you want to say that, that's fine. So step number 1. Multiply multiply the outside numbers. So you're going to multiply your outside numbers. And a reminder, imaginary 1. It's just like a variable. A radical, treat it like a variable. If there's no number in front of it, treat it like a 1. So you're going to multiply the outside numbers. Number 2, then okay, that's all right. Then multiply inside numbers. And then your last step. Simplify radicals, which is ultimately what we were just doing, prison break. You always have to simplify radicals. So ultimately, when you multiply radicals, it's a 2-part problem. You gotta do the multiplication, and then you can simplify the radicals. Okay. Example 1 and example 2. Okay. It says simplify radicals, which is prison break. Simplify radicals, which is prison break. Okay. So example 1, we have radical 8 times radical 3. For those of you who are golden on the outside numbers, you're good. For those of you who don't see it, treat it radicals like a variable. So if they don't have a number on the outside, there's an imaginary 1. So it technically looks like 1 radical 8 times 1 radical 3.
You can go down my room this time.
Step number 1 says multiply outside numbers together. What is 1 times 1?
1.
Step number 2 says multiply inside numbers together. What's 8 times 3? 24. Step number 3 says simplify radicals.
Prison break.
You're going to prison break. So we're going to break down 24. What are 2 numbers that make 24? 6 and 4, 2 and 12, 8 and 3, all good. How can I break down 6? 3 and 2, those are both primes. Going to underline those suckers. How can I break down 4?
Miss, how did you get the 18 and 30?
I didn't get 18. That's 1 radical 8 times 1 radical 3. They are not 18 and 13. I just was trying to tell you a radical is like a variable. If you don't have a number on the outside, there's an imaginary 1. Now, we end up having 3, 2, 2, 2. We have a partners. We have a set of 2s. What happens to one of my partners? It dies. Kill that sucker. The other one escapes. Don't forget, you have a 1 out in front. 1 times my escaper. 2. And then what about 3 and 2? They never had a partner on the inside. To escape, what do we do with them? You multiply them. You do 3 times 2. Multiply your inside and outside. What is 1 times 2? 2. And 3 times 2 is? You get 2 radical 6. I'll do these. You're good. Yeah. Nessa's already gonna. Go ahead and go.
I don't count this in the TA.
You still count.
No, I don't.
Okay.
Yes, so how did you only circle 2 spots and not 5?
What do you mean? You need a partner. Partner's a set of 2s.
Yeah, no, actually.
That would be 3.
Well, no, there's 2 sets of partners, why not only circle for 1 set?
Because 3 and 2 are not the same number.
She was circling the 2 that made it up.
Yeah. Here's.
And then she crossed out one of them.
I crossed out one of them.
Yeah, no, but why wouldn't she circle
The other 2 now? That's not how it works.
3 and not 2 and 2?
There's no 3 and 3. That's a 2.
Oh, no, you're wrong. Yeah, well.
Did you have a 3 on your paper?
Yeah.
Okay. Cool. I'm glad that we solved that. So I'm like, there's only 2.
For some reason I was thinking 3 times 3 is 6, but it's adding.
Yes, that's adding.
Yep.
And what is this? It's called multiplying radicals, not adding radicals. Okay. Example 2. We have 2 radical 12 times radical 5. So now I'm not going to rewrite this. I'm just going to say, remember, if we don't have a number on the outside, we have an imaginary 1. So we have 2 radical 12 times 1 radical 5. Step 1 says multiply your outside numbers together. So what is 2 times 1? 2. Then the next thing is multiply your inside, guys. What's 12 times 5? 60. So we have 2 radical 60. We gotta break down that sucker. Ariel, you're doing so good. Keep going. How do I break down 60? 2 and 30. Perfect. 2 is already a prime. Keep going. How do I break down 30? 10, what did you say?
5 to 6.
I'm gonna go with what Ariel said. I'm gonna pick it up.
15
15 and
and 2.
2? Okay, here's that. How do I break down 15? 3 and 5. So you're my prime. Yo. Step number 1 says, gotta have a breakout partner. All I got is 2 2s. 3 don't have a partner, 5 don't have a partner. What happens to one of my partners? It died. I got vicious. I usually broke holes in my paper once. Okay, what happens to my other guy? He survives. He escapes. Don't forget about this too. Remember, he's coming to pick him up. This is me driving, okay? This is exactly what I do when I drive. So that 2 is coming to pick up my other 2, right there. Tell me, what happens to the 3 and 5 who never had a partner? They don't die. They go. They never had an escape partner. They're stuck. So we have to multiply them. And they're just stuck in prison. Last but not least, simplify. What's 2 times 2? What's 3 times 5? So we end up getting 4 radical 15. So that's why your third step of Prison Break says partners inside and outside, or problems, not partners, problems inside and outside of prison multiply. So if you have multiple people getting out, multiply. And if you have multiple people stuck in prison, multiply. It's really weird because I'm like looking over here and I'm like, poor Rosalinda, you're the one fella for that. Not even a fella, you're a feller. Fella. What do they call girl fellas? Fillet. Did you say with a T? That's a fillet. Now you're a piece of meat. Okay. Stupid.
Can I go?
Yes, go ahead. Jesus, you can go as well. We'll just get this out of the way. Okay, problem number 3. Step 1 says multiply your outside numbers together. So we have negative 13 times 2. We get negative 26. Inside of our radical, we got to multiply those inside guys together. What's 10 times 2? 20. So we have negative 26, radical 20. Let's break it down.
2 and 10.
You broke down 20 into 2 and 10. Break down 10 to 2 and 5. Here are my primes. Circle your 2 and 2s. Find your partners. What happens to one of your partners? It dies, yo. What happens to my other guy? He gets out. He escapes. And what about my 5?
Comes out. Radical.
He stays in the radical. He's in the radical 5. Don't forget about negative 26. He comes to pick him up. Here I am, I'm driving to pick up my 2. He's getting out. He told me about it in his letters. Negative 26 times 2.
Negative 26 might be a felon.
52.
He might be a fella.
That's why he's negative.
Negative 52, radical 5. That's a horrible 5, but we're going with it. It's like Elvis Presley with this like extra like hood there. Thank you. So we end up with negative 52, radical 5. Write that down. Okay. Example 4. We have 8 radical 6 times negative radical 6.
Negative 8.
What?
Negative
Yep. What did you treat this negative as, Andrew?
8. What?
A 1. So we have 8 radical 6 times negative 1 radical 6. Multiply your outside together. Outside numbers together. 8 times negative 1, negative 8. Multiply your inside numbers together. 6 times 6s. What do we do?
6
6 and 6? Okay, how do I break down 6? 2 and 3. Those are both primes. 2 and 3.
So they both get out.
Okay, so I have 2 2s and I have 2 3s.
So that's 6.
I'm over here like I make lima beans.
So
They're my
6
partners.
times negative 8.
What happens to one of my partners?
Oh,
1 die. So 2 dice, 3 dice. 1 of each. Our problems inside and outside prison multiply. These 2 guys escape. So what is 2 times 3? 6. So 6 escapes. Remember, negative 8 is coming to pick that fella up. Do we have anyone stuck inside a prison? Do we have any leftovers?
Oh, they all got out.
They all got out. Here's the thing. What is the square root of 36?
There's 6.
Don't be stupid. You know what perfect squares are. Don't sit here and break it down if you know it. The square root of 36 is 6. That's why there's no leftover people. That's why there's no one stuck inside a prison. Because 36 is a perfect square. So last but not least, what's negative 8 times 6? I was wanting to see if anybody did it, but you guys told me to break it down, so I broke it down. Don't. Okay. Okay. Rationalizing the denominator. Rationalizing the denominator is going to be very helpful because when we get into special right triangles, which is going to be probably about 2 weeks, it's probably going to be the most complicated lesson, typically. However, sorry. However, it's not because it's hard. It's because there's no way to make it easy. And it's really like rote memorization. At one point, you need to just memorize. Okay? So, rationalizing the denominator. What that means is our rule for rationalizing the denominator is you are removing the square root from the bottom of a fraction. How we do that is you have to multiply both the top and bottom by the denominator. Yes. So you have to multiply the bottom by the bottom. Yes. To rationalize the denominator, you are going to multiply both the top and the bottom of a fraction by whatever's in the denominator. The reason why it works is because ultimately if you multiply both the top and bottom by the same number, it is multiplying by 1 creatively. What is 3 over 3? 1. What is 4 over 4? 1. So if I multiply by a radical over a radical, as long as they're the same radical, I'm multiplying by 1 creatively. You cannot have a radical in the denominator. It is like that vicious cycle you are just asking to be looked at like a cuckoo. It is not how we finish a problem. You can't have a radical in the denominator. So, example 1. We have 2 radical 3. So, I'm going to write it a little bit bigger, just so then it's on the video. So, we have 2 radical 3. We can't have a radical in the denominator. So, our rule says, multiply both the top and bottom by what's in the denominator. I really hope you know that the top is called the numerator and the bottom is called the denominator. If this is new, I'm sorry. So we have to multiply both the top and bottom by the denominator. So we have to multiply both the top by radical 3 and the denominator by radical 3. When you multiply fractions, you just multiply straight across. So what is 2 times radical 3? What did you say, Keelan? Perfect. 2 radical 3. We segregate. You should know this. This is why we reviewed multiplying radicals. We only multiplied our whole numbers together. We only multiplied our radicals together. We cannot multiply them together. They are not the same thing. So 2 is a whole number. Radical 3 is not. We can't multiply them again. We get radical 6. They are 2 separate things. You just get tacked together. 2 radical 3. Over, you can multiply radicals. They're like things. They're like terms. What is radical 3 times radical 3? Radical 9. The whole reason why we multiply both the numerator and denominator by the denominator is because this guy can bust out of prison automatically.
So he's 3.
You always should know.
He's El Chapo himself.
Yep, he's a perfect square. He'll always just bust out. What is the square root of 9? 3. So we have 2 radical 3 over 3. The last thing you must check is your whole numbers. Can we simplify 2 over 3? No, do not multiply them, that's division. 2 divided by 3. No, there's nothing that goes in above 2 and 3. So there's our answer. 2 radical 3 over 3. That's going to help us when we get into that. Ultimately, when we get into 30, 60, 90s. Oh yeah, and when you were here, I made it super duper easy. Not this time. I up it. Okay. Example 2. We have 5 radical 10. Again, I'm going to make it a little bit bigger for the video. 5 over radical 10. We have to multiply both the top and bottom by radical 10. And when we multiply fractions, you just multiply straight across. What is 5 times radical 10? 5 radical 10. Do not add them, do not multiply them. They are totally separate things. 5 is the whole number, radical 10 is irrational. Not a thing. So 5 radical 10 over, what is the square root of 10 times the square root of 10? Those are like terms. Radical 100. The whole reason why it's called rationalize the denominator is because the denominator ain't going to be a radical anymore. You can bust that out of prison. What is the square root of 100? 10. So we have 5 radical 10 over 10. Yes. Check your whole numbers. Can we simplify 5 divided by 10? What can we simplify? We can divide by 5, both the top and the bottom. 5 divided by 5 is? Last I checked it was 1. 1 radical 10 over, what's 10 divided by 5? 2. This is an okay answer, but if you took it a step further and know that 1 times anything is the number itself, and gave me 10 radical 2, you'd be good too. One radical 10 over 2 is the same as radical 10 over 2. Because 1 times anything is the number itself. Let's do example 3. So this one's a little bit special. So we have 6 radical 3 over radical 2. We have to rationalize the denominator. That's what it's called. So we obviously are focusing on the denominator. What do we multiply both the top and bottom by? Radical 2. We want to clear that guy out of the denominator. We can't have him. So we multiply by 1 creatively. The square root of 2 over square root of 2 is what? Multiply straight across. We have 6 radical 3 times radical 2. So 6 has no one to multiply to. 6. But then Andrew said, hey, those are like terms. Those are both radicals. You can multiply them. So the square root of 3 times the square root of 2 is the square root of 6. Over, what is radical 2 times radical 2? Radical 4. 2 times 2 is 4. Yep. Bust that guy to prison. What is the square root of 4? 2. So we have 6 radical 6 over 2. Last but not least, check your whole numbers. Do we know what 6 divided by 2 is? Can we simplify that? 2 can go into 6 3 times, square root 6. So your answer would be 3 radical 6. Questions? It's a relationship between triangles, essentially. Yeah, I actually taught you guys the whole thing and you guys just went, so. Alright, geometric mean. Literally the new stuff that should be new. The geometric mean. Ultimately, this is what the geometric mean. For any two numbers, for any say, we'll call it A and B. So any two numbers, A and B. When I use letters, that just means I'm arbitrary. Arbitrary means random. So for any arbitrary numbers, A and B, the geometric mean is the positive number for x such that, here's our formula, A over x is x over b. And better yet, what I call it is something over x equals x over something. So A over x is equal to x over b. It's a proportion, it's a relationship. And the reason why it says a positive number is because we're going to be getting into square roots and we're going to be simplifying radicals. So this is why I reteach you prison break, is because it comes back to this. When you square root a number, technically any square root is always positive and negative. Because think about it. If you had x squared, if I had 2 squared, what is 2 times 2? 4. Well, that's a positive 2. Oops. What if I had negative 2
Well,
squared?
if you had negative 2, so
Exactly. Negative 2 times negative 2 is positive 4. So the reason why it says the positive x is because negative 2 is unrealistic. We're talking about triangles. Can you have a negative 2 length of a triangle?
No.
No. So that's why we're only going to ever focus on the positive. That's why the majority, when we're talking about square roots, we're always going to be talking about positive, because we're talking about real life. We're talking about things that are tangible. You can't have a negative debt in a figure. That would be really weird. I have this triangle that you owe me from like 3rd grade. And you're like, okay, that was just me talking. You didn't necessarily have to write that down. All right, so let's do the geometric mean. But good. Not like it's going to hurt you. So it says, what is the geometric mean of 4 and 18? So the formula for geometric mean is something over x equals x over something. Oh yeah, I say something. I give you the somethings. 4 and 18. It doesn't matter where you place them. If you did 18 and 4, that wouldn't matter. They just go in your sums. I give you your 2 values because it says for any random number, A and B. That's A, that's B. Cool. Now, we have a proportion. How do we solve proportions? Cross multiply. So we're going to multiply 4 times 18. That is equal to x times x. 4 times 18. I got 72. Is that what you said? Oh, I heard 18. And I was like really thinking about it. That's why it took me a second. Sorry, Andrew. 4 times 18 is 72. What is x times x? 2x is saying I have 1x and I have another x, so I would have 2 of them. Like I have 2 fingers. When you multiply, you have an exponent. We have x squared. Did we show you guys the exponent song? We're going to play it next. So 72 is equal to x squared. Now, the glorious thing about math, I love it. I love it. The one thing I love about math is no matter what you do, there's always a way to go back. Always. So to undo adding, we subtract. To undo multiplying, we divide. To undo squares, we don't multiply. We put in the radical. We square root. When you guys get into Algebra 2, when we do exponents, so like exponential growth and decay, some of you guys learned that in 1C. If you do exponential growth or exponential decay, to undo exponentials is logarithms. To undo trig is inverse trig. To undo derivatives is integrals. Always. There's always a way to get back. That's what's so glorious about math. So to undo a square, you square root. What you do to one side, You gotta do to the other. So the square root of x squared, ultimately they cancel each other out. You're left with x. Now, I'm pretty positive if you put x, or the square root of 72 in your calculator, you would get some decimal. I don't want a decimal. And I don't know how many times I remind my students this. I can walk it on this. I don't know how many times I tell my students this. They still end up giving me the decimal. So think about on a test, you're going to be wrong. I want you to be able to simplify the radical. I want you to prison break. So we got to break down 72. What two numbers make 72?
Teachers and students, please remember,
Put that in.
passing time has ended. No one should be
So
out of class.
2 is a prime. How do I break down 36?
Turn back at this time. Thank you.
How can I break down 6? 2 and 3. And I can break down the other 6 into 2 and 3. So here are all my primes. I have 2, 3, 2, 3, 2. So circle your partners. I have 2 2s and I have 2 3s, my lima beans. What happens to one of my partners? They die. Each group, a partner dies. So a 2 dies and a 3 dies. So I have 2 partners. I have a 2 and I have a 3 getting out. What do I do with those 2 and 3? Multiply. So 2 times 3, we multiply. So 2 times 3 is 6. Who never has a partner to get out? 2. He's stuck in that radical. So x is equal to 6 radical 2.
So when we get to that point, you should want us to factor them all.
Yep. Don't put it in your calculator and get a decimal. If I asked you to do that, I would have told you. If I wanted it to be that simple, I would have never reminded you how to prison break. Okay, let's do another one. We want to find the geometric mean of 5 and 15. Our formula for geometric mean is something over x equals x over something. This is like Nessa's favorite. Well, one of the favorites.
It is.
She has like 900, I swear.
Miss, when it comes to trivia, you're gonna play them the song.
Yes, of course I do. So what are our A and B? What are our somethings?
5.
Perfect. 5, 15. If you do it backwards, you're good. You're golden. You're golden spoon. How do we solve proportions? Cross multiply. 5 times 15 equals x times x. What's x times x? X squared. What's 5 times 15?
75.
75. How do we get, I don't want x squared. I want x. I'm ultimately replacing them in my proportion. I want my x's to be the same. So how do I get x by itself? You do a radical. You square root. The square root of x squared is? X is equal to the square root of 75. I don't want a decimal. Don't you dare put in your calculator the square root of 75. I would have asked that, I would have said that. Prison break. Give me 2 numbers that multiply to make 75. Sure, 5 and 15. 5 is a prime. How can I break down 15? 5 and 3. My other primes. Do I have a set of partners?
Circle 5.
I have 5s. Circle them. Oh, I just saw it. Hiram's like, oh, I'm dying. 5. What happens to my other 5? He gets out. He escapes. What about radical? Or what about 3? He has to stay out. He has to stay inside. He never had anybody. We would only multiply if there was like another friendly guy out there. If there was like a 2 or something. Since he's by himself, he would just be by himself. So 5 radical 3 is x. Well, not bad. When you see it in a picture, it's not so beautiful though.